All right, welcome to a very quick presentation on our climate. And there are a few things that I really want you to know, mostly how humans affect climate change, how alternative energy is a great solution to that, and what alternative energy sources there are. So let's first talk about our climate. First of all, remember that the carbon cycle is a balance of these two reactions, super important. We are upsetting that balance. When we burn fossil fuels, we take all those carbon atoms that were alive a long time ago and have been buried as a fossil, and we're basically bringing them back up to the surface. That extra carbon dioxide adds to the greenhouse effect. So the greenhouse effect is not bad, but if we have too much of it, it is bad. Now, this is a test question. Current environmental issues are kind of small because of this greenhouse effect, but the way research is showing us and data trends is that they will get worse. Right now, photosynthesis is the only way to get this extra carbon dioxide out of the atmosphere. A couple other things, test questions here. Weather refers to conditions for one day. Climate is long-term changes. So they look at trends for years and years and years, and they're looking at the climate changes. So if we have a warm day in winter, we're talking about weather. That's not a climate change. So when people say, hey, it's really warm today or it's really cold today, those scientists are wrong about climate change. You are talking about weather if you talk about one day. So make sure you know what you're talking about. They're very different definitions for those two words. You need to know what the greenhouse effect is, and it is simply this. Radiation comes from the sun. A lot of that radiation hits the planet and bounces back and goes right back into space. Some of that radiation is absorbed by our planet. The greenhouse effect is the fact that there are gases right here that reflect some of that back to Earth. So the greenhouse effect is why we have a green planet, because some of this radiation is absorbed, a lot of it goes back, but then some of it gets reflected back to Earth. And it's this reflection back to Earth that makes our planet warm and gives us plants and gives us all life. The problem is if we have too many greenhouse gases up here, too much gas or too much heat gets reflected back and we get too warm. So what are the greenhouse gases? There are actually 4 of them: nitrous oxide, methane, water vapor, and carbon dioxide. Of these 4, methane does the best job at reflecting heat back. Most of it is man-made, but there's not a lot of it in the atmosphere, so we don't talk about methane a lot. Water vapor is pretty good at reflecting heat back to Earth. We cannot control the water on our planet. We're always going to have evaporation. There will always be humidity, so we can't do anything about that. So again, we don't talk about water vapor as being a greenhouse gas because we can't control it. Nitrous oxide is another one. Some of it is caused by industry, but again, there's not much of that in the atmosphere, so we don't talk about that. The greenhouse gas that gets the most news coverage is carbon dioxide, because there is a lot of it and it is the only one that we can actually control. So how do we control it? A little background on nitrous oxides, a little background on methane. It does come from cows or manure and any of us going to the bathroom or passing gas. And let's talk about carbon dioxide. Before we can, you need to understand what a positive feedback loop is. So a positive feedback loop is where the outcome of a reaction makes the reaction keep going. And the best example of this would be a street fight. So if you came up and hit me, I'm probably going to hit you back. And then if I hit you back, you're probably going to hit me. And that reaction keeps escalating. It's a positive loop because my reaction of hitting you back makes you redo your reaction. Another example of it is labor pains and childbirth or contractions. So gravity pulls the baby down. When that baby puts pressure on the opening, that pressure makes the uterus contract. When the uterus contracts, the baby pushes down more, which makes the uterus contract more. So the fact of that baby falling down makes the uterus contract and makes the baby fall down more. Those contractions keep happening, or this street fight keeps happening until there's just an end. Somebody dies in the street fight or the baby comes out. All of a sudden, those contractions or that pressure on the uterus stops until the contractions stop. Negative feedback loop is just a more normal reaction where the outcome of the reaction makes the reaction stop. So positive feedback loops are the weird one, and the greenhouse effect is a positive feedback loop. Here's what's happening. Carbon dioxide makes our planet warm. That's a normal thing. When our planet gets warm, more water evaporates. Water vapor is also a greenhouse gas. So as we keep adding carbon dioxide here, it causes more evaporation, which makes more water evaporate, which makes more evaporation, which makes more water evaporate, more warming, more evaporation, more water. It keeps cycling. So once we've got this carbon in the atmosphere, we can't stop this positive feedback loop. The only thing we can do here is take away what's stimulating it. So take away this extra carbon dioxide, because water vapor is a greenhouse gas and it will keep making this worse and worse and worse. Couple extremes to think about if you don't think this is serious. Venus is super hot, Mars is super cold. It's all about carbon dioxide. So Venus has 300 times the CO2 as Earth. Mars hardly has any. Because of that presence or lack of presence of carbon dioxide, we have extremes in climate. Here's some data that shows the levels of carbon dioxide in our atmosphere. Scientists study this mostly by looking at air bubbles that are trapped in ice sheets in the Arctic. So they know how old the ice is because of layering that happens every year of rainfall and snowfall. And they can count back layers in the ice sheet, find air bubbles, and measure the carbon dioxide in those air bubbles. This is where we are right now. It is going up exponentially, and that has never happened before. So we should be a little bit worried. Does carbon dioxide affect temperature? According to this graph, it does. So global temperatures always fluctuate during winter and summer, but if you can see or notice here, there is a trend that as carbon dioxide goes up, global temperatures are on average also going up. Scientists predict that we will be up 2.5 to 10 degrees in the next century. That is a big deal because during the Ice Age, the average global temperature was only 5 to 9 degrees colder. So what do you think is going to happen if we get 2 to 10 degrees warmer? It could be a very different climate on our planet. We have already increased 1 degree since we hit the year 2000, and we don't want it to go any higher. So what is the outcome of rising temperatures? More droughts and wildfires, so more extreme weather like that, more storms. Sea levels will rise when polar ice caps melt. Species will not be able to adapt quickly to this new climate, which means they'll go extinct. So we're losing biodiversity. We are already seeing this. All those wildfires in California are a result of droughts. They're all a result of climate change. We have had more tropical storms this year than we've ever recorded. In fact, they've already gone through the whole alphabet of naming tropical storms, and they're back at the beginning. And we are seeing sea levels rise. Also, air pollution. Simply having this carbon dioxide and carbon monoxide in the atmosphere, you can see that pollution. In China, there are people that wear masks all the time, not because of coronavirus, but because their air is so dirty. Keep in mind that most cities were built on the coastline because that was where trade happened. 40% of the world's population lives within about 50 miles of the coast. If we increase ocean levels, we're going to lose these cities. New York City is about 3 feet above sea level. New Orleans is actually built below sea level. So as water levels rise, all these people are going to need a place to live, and they might try to come live in Minnesota. So we have to be ready to welcome people into our border. This will be a picture if we had extreme sea level rise, so all the polar ice caps are melting, all of these cities would be gone, which means all those people are either dead or they're moving in to live with us. Here are some pictures that it actually is happening. This is 100 years ago or 150 years ago, the Glacier National Park, sorry. And this is what it looked like 15 years ago. So we have lost all of this ice already. Here's a global view, same time of year, so it's not a winter-summer thing. This is polar ice in 1979, polar ice in 2007. I am not into any extreme type of thinking. It's good to look at the other side of this story, but most data shows, and 99% of all climate scientists agree, that increased carbon dioxide from man-made activities is making all this happen. You're going to read an article about what could happen in Minnesota and answer some questions, but it will affect us. Extreme heat, heavy rain can all affect our infrastructure. It affects our agriculture, which affects our health. It affects our jobs, air quality, and water quality, and all that stuff. So we study the environment because we want to feed the world without destroying it. We want to have air conditioning and refrigeration in cars and airplanes. So can we make all that happen without destroying our environment? Can we keep our air clean and our water clean so that we can live? One of the ideas is if we were all vegetarians, vegetarian diet, so producing all of this type of food, the green part of this line is emissions, and actually the total line is carbon emissions. So to make a lamb steak for you, you put out this much carbon. To eat some beans, only this much carbon is produced in farming. The main solution here is to have alternative forms of energy that do not have to burn fossil fuels. We'll talk about these in class. And just a funny look at this, how could a species that's supposed to be successful end up killing itself within a few million years? And that is where we're headed if we don't watch our environment.